Hello, everyone. Good morning, good afternoon, and good evening to all. Dear authors and invited guests, welcome to the technical session 8A. I am Anisha Mishra, the moderator of this session on behalf of Global Knowledge Research Foundation. It is my great pleasure to welcome you to the 6th World Conference on Smart Trends in Systems, Security, and Sustainability through Zoom. I hope you will enjoy the knowledgeable and interactive sessions through the day. There is a special note for all the presenters. You will be given 12 minutes for your presentation and 3 minutes for question and answers. On 10 minutes, I'll raise a gentle reminder. There's another request to all the participants that you please stay connected with us till the closing of the session. If you have any update or query, you can write it to me in the chat box. So just before we get started, I would like to introduce you all to the chair of the session, Professor Sheng Lung Tang. Professor Sheng Lung Tang is a professor and the director head of the Department of Creative Technologies and Product Design, National Taipei University of Business, Taiwan. He received a PhD degree in computer science from the National Tsinghua University, Taiwan. He is an honorary professor of Beijing Information Science and Technology University, China, and a visiting professor of Ningxia Institute of Science and Technology, China. He is also an adjunct professor of Mysore University, India. Dr. Peng has edited several special issues at journals such as Soft Computing, Journal of Internet Technology, Journal of Real-Time Image Processing, International Journal of Knowledge and System Science, MDPI algorithms, and so on. His research interests are in designing and analyzing algorithms for bioinformatics, combinatorics, data mining, and networks, areas in which he has published over 100 research papers. Welcome to the session, sir.
Okay, thank you very much.
Yes.
So can we start this session?
Yes,
Okay.
sir. Now we'll start with the session.
Yes.
So I would like to invite our first presenter, Jiva Nantella, and the paper title is IoT-based data security and protection for hospital information systems, a knowledge graph analysis. Dear presenter, you may please start your presentation.
Hello, my name is Jiwa Nkela Oga, a PhD student in computer science at Université d'Abomey-Calavi, Institut de mathématiques et de sciences physiques, Benin. Benin is in the west of Africa. It is a great pleasure for me to participate in this conference. Here is the outline of our presentation. First of all, we have introduction. Secondly, the methodology adopted for our research. Then the bibliometric results, which concerns co-authorship and countries, co-authorship and authors, organization illustration, co-citation and cited references, source iteration, then follow contribution and limitation. We will finish with conclusion and future work. Introduction. This research work proposes a knowledge graph analysis of hospital information system. We have a question. What is the issue? The problematic at the outset posed to conduct this research is which bibliometric database to choose for our study. Dimension database and both viewer software were chosen. Now, what are the research questions? They are, first, what are the most relevant sources in the area of IoT security and data protection for hospital information system? Secondly, which country and university had published more papers? Which authors and papers have been consulted the most? And then what are the three most cited references and authors. Let us continue with the methodology adopted. In this paper, the extraction of data is in the dimensions database, where for the bibliometric study was performed on December 20, 2021, and updated on March 12, 2022. So the search string used for the extraction is IoT and data and security and protection and hospital and information system. After the export and download, the downloaded file is zipped and extracted into a CSV file used in VOS viewer in order to establish different possible joins. Our research focused on the most cited sources, co-authorship network, co-authorship, co-citation, and citation. What were the results of our bibliometric study? These results were based on co-author and countries, co-authors and authors organization illustration, co-citation, and cited references, and then source illustration. Now we are on figure 1, histogram of co-authorship and countries. This figure represents co-authorship and countries, as I have said. On the x-axis, s-axis here, we have countries. We are countries such as United States, China, India, United Kingdom, up to Greece. And at the y-axis, we have documents. We notice that we have 690 publications which have been made by United States. So we can stress that the United States is a reference in the field of IoT data security and protection for hospital information system. Let us continue with the figure 2, co-authorship and authors illustration. This figure, as I have said, presents co-author and authors. We notice that the authors, Zadin Bibi, has the highest total link strength equal to 40 here. Therefore, he is the one who has published the most in collaboration with all authors in the field of IoT security and data protection for hospital information system. Figure 3, organization illustration. As I have said, this figure is an illustration of a university represented by circles. So, the most represented university is Velouré Institute. So, we can say that this university has the first place in terms of publication of papers. Let us continue with figure 4. We have here authors on x-axis and cited references on y-axis. Here, the 3 most cited references are Boubi, G et al., Atzuri et al., and Al-Fuga et al. On the last figure, we have the sources represented by circle. The most relevant source is the IEEE access source here, with 283 published documents. This is because many journals focus on IoT source and health, but few are used in the field of IoT-based smart health. Encyclopedia here of big data came in second position with 244 papers, followed by lecture note here with 159 papers. What are now the contribution? This study is a great step forward in scientific research as it identifies the most relevant sources in the fields of IoT security and data protection for hospital information system to determine the most consulted authors and papers in this field. We found that even the major journals have not found the importance of focusing on IoT-based smart health. The research because it appears that the area does not yet have a large influence. For our limitation, we use the dimension database and post-viewer software for our study. The database dimensions may not be sufficient for a comprehensive study. The Web of Science database could also have been used for our studies, of course. Conclusion and future work. A bibliometric analysis conducted from 2012 to 2022 showed that the fields of IoT-based smart health research born from 2014 and continue to grow. This study provides important knowledge support for future research and provides first the most relevant sources, then the country and university with the most published articles, then the most consulted authors and articles, the three most cited references and authors. Our future work will focus on the state of the art of IoT security and data protection for hospital information. We are at the end of our presentation, so we thank you for your kind attention.
Any question? No?
Hello, I'm at end.
Okay. So can we move on for next paper?
Yes.
Okay. Thank you.
Yes, sir. Thank you also, sir.
Thank you.
Thank you, Professor.
Okay, thank you for your great presentation. So we
Thank you.
will move further to our next paper. And the presenter name is Ingrid, and the paper title is Design and Application of the AHP TOPSIS 2N to Evaluate Linked Open Government Data from the Electricity Datasets. Dear presenter, you may please start your presentation. I think she is not in the session. Okay, so we'll move forward to our next paper.
Okay.
And the paper presenter is Yaroslav Yurchushin, and the paper title is Modeling of Blood Flow Processing in a Living Organism. Dear presenter, you can start your presentation.
Hello.
Yes.
The presenter name is the correct name is Vasil Yurchishin. We asked to change it since there was a mistake.
Okay, sorry for the mispronunciation.
Yes, Vasil Yurchishin is correct one.
Okay.
Thank you. And as the presenter will make his speech in Ukrainian, it was agreed before. So and since the speech is in Ukrainian, there is no presentation, so he will make a speech from himself. Please, I give him the word.
So he's not here in the session. Will you be presenting on his behalf?
No. He will make his speech, but not in English, but on Ukrainian.
Okay, but I think we'll not be able to understand the presentation then.
We make a question regarding this question before, and the answer was that it is possible to make presentation in Ukrainian.
Okay, in that case, you can go ahead.
Thank you. Please go.
Доброго дня, пані і панове. Вітаю вас, багатостраждальної країни, з самого її серця. Ми раді, що ви з нами, і щиро дякуємо вам за це. Моделювання живої матерії має велике значення не тільки для медичної науки, але, зокрема, для...
Excuse me, sorry for the interruption, but you have to show the PPT also. Are you presenting?
No, because there is only a speech, not presentation.
Okay, go ahead, please.
Ці питання як надзвичайно цікаві, так і надзвичайно складні і необхідній мірі недосліджені. І нашу увагу в цьому привертає система кровообігу живого організму як складний механізм, в якому ми бачимо певні аналогії і закономірності суто технічними пристроями. При цьому вважаємо, що багатьма технічними напрацюваннями можна скористатися при моделюванні серцево-судинної системи, і те, що ми пропонуємо, ми не знайшли в публікаціях інших науковців. Можливо, ми не надто ретельно шукали, і хтось із науковців знайде подібне в інших. При такій ситуації вважаємо нашу доповідь черговим привертанням уваги наукової спільноти до цього питання, бо, на наш погляд, воно є надзвичайно важливим і назрілим. Ми переконані, що серце – це не насос кровоносної системи. На наш погляд, воно виконує інші функції. При цьому звертаємо увагу, що це думка науковців технічного спрямування, а не медичних фахівців. І в цьому плані у нас немає експериментальних підтверджень. В даному випадку ми розглядаємо це питання не як медичну систему, а фізичну. І саме в цьому аспекті пропонується її розгляд. Ми не розглядаємо кровоносну систему як систему транспорту поживних речовин організму. Ми це сприймаємо як доведений і неспростовний факт. Але в цьому ми вбачаємо іншу роль серця. Для нас серце – це не насос, а значно складніший механізм, дія якого приводить до руху крові по судинах. Воно як спусковий механізм в пружинному механічному годиннику, але не тільки як спусковий механізм, а серце – це ще генератор відповідних хвиль, як своєрідний резонатор Гельмгольца. Ми не виставляємо для обговорення результатів експериментів і досліджень. Це наше сприйняття цього процесу, і ми виставляємо на обговорення наші думки науковою спільнотою. Нам цікаво почути в цьому плані думки інших науковців. Тобто дану роботу ми розглядаємо як дискусійну. Технічний прогрес стрімко вірвався не тільки в наше повсякденне життя, вражаючими інформатизацією, технологізацією, роботизацією, здобутки в сфері IT, штучного інтелекту. Особливо нас вражають досягнуті на сьогодні технологічні норми порядку 1 нанометру. Я пам'ятаю ті часи, коли нас вражали технологічні норми в десятки мікрометрів. Не залишилась при цьому на узбіччі і медична галузь. Сучасні науково-технічні досягнення допомагають боротися з недугами практично всіх органів людини. Сфера впровадження інформаційних і технологічних і технічних технологій охорони здоров'я набула великого Цими питаннями займаються багато відомих організацій. Тисячі медичних установ використовують їх здобутки. Розглядати ці питання не є темою даної доповіді, тому на них зупинятися не будемо. Ми хочемо розглядати кровоносну систему живого організму як фізичну систему і розглянути модель її функціонування в іншому плані, ніж прийнято. Ми не будемо зупинятись на запроваджених моделях серцево-судинної системи. Вони достатньо описані і запроваджені. Але нам здається, як фахівцям технічного спрямування, що вони не точно відображають справжній стан цієї системи. Рух крові по судинах має хвильовий характер, але він не схожий на добре вивчені звукові, світлові, електромагнітні хвилі або хвилі, які описують квантові явища. Всі ці хвилі відображають їх лінійні взаємодії. Їх можна додавати. При накладанні двох хвиль виникає хвиля, форма якої визначається простим додаванням двох початкових хвиль. Ну, звичайно, ця властивість лінійності є наближеною і при певних умовах може там порушуватися. Хвильовий процес руху крові по судинах відображає нелінійні взаємодії. При цьому ми вбачаємо, що енергетичні потреби забезпечення функціонування живого організму і можливості серця для забезпечення функціонування не є співставними. Ну, хтось може заперечити. Я цього дійшов після ознайомлення з книгою американського професора Ірвінга Германа «Фізика людського тіла». Він там таке не пише. Я цього дійшов, уважно ознайомившись з його роботою. Можливо, це моя імпровізація. В середньому за добу людина витрачає 4,5 тисячі кілокалорій або 18 855 кілоджоулів. А калорійність добового раціону 3,5 тисячі кілокалорій. Це не результати наших досліджень, це дані з інтернету і наукових видань. Ми не наполягаємо на їх точності, але вони для нас багато про що свідчать. Адже тільки серцю для перекачування крові за аналогічний період потрібно енергії більше. Крім того, вражає те, що, наприклад, пересаджене серце однієї людини іншій відновлює працездатність явно швидше за повноцінне функціонування пересаджених чи просто пришитих інших частин тіла. Складається враження, що йому, то є серцю, щось допомагає в цьому. Або ми не зовсім розуміємося на цих процесах, що більш ймовірно. Ми вважаємо, що серце не виконує функцію насосу для забезпечення руху крові по судинах, а хімічні процеси не є основними для підтримки необхідної температури тіла. Ми сприймаємо кровоносну систему як систему транспорту поживних речовин організму і сприймаємо це як доведений і неспростовний факт. Але в цьому ми вбачаємо іншу роль серця. Для нас серце вже давно не насос кровоносної системи, а складний багатофункціональний орган, який виконує в дуже грубому наближенні щось на кшталт спускового механізму у механічному годиннику і являється своєрідним резонатором Гельмгольца, створюючи солітонні процеси в системі кровообігу. А необхідна температура тіла забезпечується рухом крові по судинах по аналогії роботи побутового холодильника, як температура охолоджуючого радіатора, тобто решітки, задньої стінки домашнього холодильника. Ще відкривач солітонів Джон Скотт Рассел позаминулому столітті експериментально показав, що яка поширюється вздовж живого тіла із збереженням своєї форми та швидкості при демонстрації здатності до неруйнівних зіткнень. Властивість солітонів виконувати роль локомотивів для транспорту порції речовини в необхідне місце в межах солітонного середовища по законам нелінійної динаміки заслуговує при цьому неабиякої уваги. При цьому слід зауважити, що біосолітонна фізична енергія здатна гармонійно співіснувати в живому організмі з відомими хімічними видами його енергії. Це встановлений факт. Також відомо, що у людського ембріону у віці 3 тижнів, коли він має розмір всього кілька міліметрів, першим приходить в рух серце. Початок серцевої діяльності обумовлено якимось внутрішніми енергетичними механізмами, так як в цей час в серця ще немає ніяких нервових зв'язків для керування цими скороченнями, і воно починає скорочуватися, коли ще немає крові, яку потрібно перекачувати. В цей час сам ембріон представляє собою кусочок полімерної слизі, в якій внутрішня енергія самоорганізується в енергоекономічній пульсації. Аналогічно відноситься до виникнення серцевих скорочень в яйцях та ікринках. Подібні форми енергетичної самоорганізації та самолокалізації відомі в полімерних сполуках, втім рахунку там не біологічного типу, і мають солітонну природу. Так як солітони виявляються найбільш енергоекономічними самоорганізуючимися структурами пульсуючого характеру. Чому ці питання зацікавили нас? Для відповіді на це відійдемо від технічних і медичних моментів і розглянемо деякі побутові. Моя дружина має так званий негативний резус-фактор. Я добре знаю, що це таке, і не з літературних джерел, а з повсякденного тривалого життя. Її 2 дітей мали позитивний резус, і я бачив, як відбувався їх прихід в цей світ. Я і зараз бачу, як вони синіли і жовтіли, і ще й досі відчуваю жах, який охоплював мене тоді із-за страху втратити їх. Лікарі заспокоювали...
Dear presenter, sorry for the interruption. You have only 1 minute left. Please conclude your presentation.
Отже, можна зробити висновки, що рух крові по судинах має хвильовий характер, але він не схожий на добре вивчені звукові, світлові, електромагнітні хвилі. Хвильовий процес руху крові по судинах відображає нелінійні взаємодії. Рух крові по судинах носить солітонний характер, і якщо прийняти це і зосередитись на дослідженні такого підходу, то є підстави сподіватися відкрити немало нового і раніше невідомого в плані функціонування живого організму і моделювання живої матерії. І серце не виконує функцію насосу для забезпечення руху крові по судинах, а хімічні процеси не є основними для підтримки необхідної температури тіла. Thank you very much.
That's all.
Okay, thank you. It's really an unusual presentation. Okay, thank you. So let's go to the next paper. Ingrid?
Okay, sir.
Okay.
Yes, so we'll move further to our next paper. I think Ingrid is here, so she'll present now. The presenter is Ingrid, and the paper title is Design and Application of the AHP TOPSIS 2N to Evaluate Linked Open Government Data from the Electricity Datasets. Dear presenter, you can start your presentation now.
Okay, let's share my. Okay, share my screen. It's share my screen, okay?
Yes,
Okay.
it's visible. Okay, you can please go ahead.
Okay. Hello, everyone. Good morning, good afternoon. I'm Ingrid Palma. Sorry, my camera is off, but I go ahead. But first of all, I would like to say thank you for the organizations of the conference and the invitations to be here. And I'm so glad to propose to design an application of the HEP TOPSIS to evaluate linking open government data from the electric power data sets. Firstly, I show a brief the context on the complexity behind the opening data process. It's important. The 5-star schemes illustrates the evolutions of the open data standard, which goes from the simple to the most complex open level of semantic web, allowing the effectively open data. These 5-star linked open data refers to an incremental framework for deploying data, and Berners-Lee, the inventor, the web, suggested this scheme for linked open data project. This system is a cumulative, it additional stars, and a little more about these motivations of this work. There is a governmental motivations, laws, decrees, and among all the national and international regulations, and that fosters initiatives and strategies for the implementations and publications of the datasets in open formats. And in Brazilian government, the open data is a legal obligations. In the Brazilian context, having an example, the current open data policy, which show the main principles and address to have followed about the opening data. It is Open Data Plan, called PDA, is an instrument created to execute to implement these policies. The PDA, Open Data Plan, promotes and defines some criteria for the opening data and the published data in the Brazilian Open Data Portal. And about my motivations as research problems, despite the many actions implemented to the PDA, the plan data actions, it's evident in my recent studies present by Palma, Ladeira, Reis, the increased demand for electric power data, and allied to this problem, and less the 0.5% of the whole data sets published on the Brazilian portal Open Data is a refers the main governmental portal to centralize all open data. I said before, is refers to data sets power electric power. At all, the open data creates opportunities for economic development, but on the other hand, risks there is risks associated to complexity of the process for opening data. Potential risks as misinterpretations, misuse, or no reuse of the data sets. Results on aversions or resistance to opening data by the public managers. Okay, the surveys shows a research gap related to the lack of the models, formal methods and the models that support the evaluations electric power open data. Thus, is the governmental context assessing the level of openness of data in the electric sector. So the data sets made available in the Brazilian portal are closer to the open data standards to illustrate the research problem to be explored. For this, a decision support model was proposed to evaluate the opening electric power data level based on the risk criteria related to open data. So it was necessary to define risk criteria relevant to this context, the open government data, to select the methods of decision support compliant to the study, this problematic, to design the model by considering the risk criteria defined in the method found. And in the last one, to validate the model using sensitive analysis. This figure illustrates the methodology I used, which was structured in the 4 phases. The first one, the planning disruptions, deals with the context, my background, with definitions, my context, my problems, my goals, definitions. The second phase is systems review literature, executing the constructions as a truly. This phase conducts the service to identify the most appropriate and the effective risk criteria, and this method used in the related work. Okay, it's important to find this criteria, my main criteria in my methods to relate this work. The third phase refers to all stages of the model design was used to seminal framework the CRISP-DM. The MCGA implements this stage decision support process model. And the last one, the editorial finding phase is the most qualitative, where I present my recommendations, my results, my suggestions. After selecting my alternatives, this example, the one data set I found, from the data set selected to you evaluate. For this, I needed to identify open energy data requirements or metadata to the methods on the literature study too. These are used to weight my criteria. Where identify 6 principles for linked open data, 8 principles for open government data. Based on these principles, it was possible to identify the main risks related to open data standard. For the map, my main criteria, my survey is used to, in addition to support the risk criteria, it helped me to find the most used methods in related work. Highlighting on the hybrid method, HP Topsys, mentioned by Kubler and Sheikh. 7 to 8 risk criteria were found in this survey. It's possible to note to rate of 6 criteria per work, related to work. And this scheme shows the criteria defined, this decision problem, called hierarchical decompositions of the problem. And the first level shows the objectives of this work. The second level, my dimensions or criteria found. And the third level to 12 criteria consolidate in these 5 criteria. In the last one phase, show the result, my result, which is the alternative classified according to the level of the openness, open openness. The model has main drivers. the defined criteria is my inputs, my drivers is a risk criteria, and my alternatives and are the data sets, open electric power data sets, and the process involves the HEP method for calculate criteria weights in the top 2n for data sets, rank data sets. I define HEP tops to N to use in my model. The technique for the preference by similarity to ideal solutions, TOPSes. It's evaluate the performance of each alternative, my data sets, concerning and proximity, similarity to ideal solutions. The TOPSes technique confers the rank of the best alternative to the one closest to the positive ideal solution. The best alternative has the shortest distance from these positive ideal solutions and the farthest from the negative ideal solution. The TOPSes has the 7 steps. I show you the choice for the hybrid HEP TOPSes methods is justified by the quantity of elements of the problem and reduction of computational complexity. Allows the generations of 2 ranks, and the effective integrations of the risk criteria to decisions makers' preference. These I show results of this process in the matrix that found the measures for validations of the rank generated by TOPSes. You notice 2 normalizations is a differential of the TOPSes. They generate 2 ranks to validate my model. And a big change each other. The bump chart is an update for line chart, also known as rank chart, is an evolution to line chart used to compare dimensions to each other. It been useful for exploring changes is the positions, the rank and performance each set of it. This. In the other versions, the 5-star systems, the SCAM 5-star, classify as the basis data sets according to the openness level in light of the open data standard and the open government movement. The radar chart presents another way to show and analyze the same rank. And it's possible to evaluate, to get insights about the data sets in relation to the rate performance of the alternatives.
Sorry for the interruption. You have only 2 minutes left. Please conclude your presentation.
Okay, for this, the following data sets was select the best, the worst in the intermediate, the middle of the rank alternatives, and allows managed experts to make more specific analysis and verify which criteria is more impacted. Okay, final remarks. To final this model to allow high values data set evaluations and performance to the open data standard frameworks focus to the government of open electric sector, and this methodology incorporated to the review and elaboration of the new open data plan and the versions, the web versions now by Shine R of the model facilitates more comprehensive allows insights to the analysis and evaluations to be performed by the public managers. Okay, potential methodological instruments for innovation, especially in the public sector, is a positive change in the culture of transparency and the open data policies for electric power sector. In future works, I suggested the applications of the model including new metrics, criteria, and alternatives to parameterizations, hybrid HEP top-to end methods. Thank you for your attentions.
Okay. Any question? No?
Yeah.
Okay. Thank you very much. Okay, let's go on to the next paper. Thank you.
Okay, thank you for your great presentation. Now we'll move forward to our next paper. And I would like to invite Hanif to present his paper on the title, Graduation Level Prediction by Using Classification Algorithm, Case Study of E-Learning in Telkom University. Dear presenter, you may please start your presentation.
Okay, thank you for the time. First, I will share my presentation. Okay, have you seen my presentation clearly? Okay, first, I will say thank you for the time. In this time, I will present our paper. Our paper title is Graduation Level Prediction by Using Classification Algorithm, Case Study of E-Learning in Telkom University. My name is Hanif Fahuja, and I'm from Telkom University. E-learning is one of the technologies used to support the learning process in university level. And Telkom University, with the university based on technology, Telkom University so intensively apply the learning using e-learning in order to become effective and efficient method. E-learning is used to reduce the cost and time spent learning in an offline class. And with a learning review system can be done anywhere because students do not need to come to the classroom to study, and simple by passing the internet network can already attend the class. And here the example of e-learning management system in Telkom University. And currently this kind of process e-learning has become mandatory in certain university to support the learning process such as Telkom University. By prioritizing technology, Telkom University is applying many modules, component, and various type of approaches to allow this kind of learning model to get accepted by students and catering their diverse and different characteristic. As you can see in this slide, you can see the example view of learning management system in desktop version and mobile application. And in this case, the Moodle Telkom University as the platform used in a learning process will become the object of research, where the data specifically related to the courses at the Faculty of Engineering and the application of graduation prediction become the theme to rise by modeling the prediction through the graduation rate from the student based on the percentage of the course. Okay, in this case, I use predictive analytic, and commonly the technique used in the data mining was classified into supervised classification, decision tree, Bayesian, neural network, association rule meaning, regression, etc. And as we know, unsupervised learning, for the example, clustering, association, and etc., which is based on the extent of the model development to identify the attendance of analysis or estimation, where certain algorithm has been used to discover a problem and prediction respectively. And the data mining method is considered to be the most effective for processing data that has been obtained from e-learning, because this method has been extremely popular in terms of extraction process of unknown or raw data into useful data in the form of information. From this concept, it be taken that the data originating from e-learning is in the form of abstract data, which will later to be used as useful information in the form of prediction model of prediction model of student graduation toward the subject. With this concept, the researcher will compare three algorithms, namely C4.5, naive Bayes, and Bayesian network algorithm, which are based on the literature that can be gathered so far by the researcher by comparing several algorithms. And there are three that have been the best performance. C4.5 algorithm is the popular algorithm in the classification process, where use the decision tree concept, in which there is a tree-like structure that start from the root attribute and end with a leaf node. Then there is the native Bayes and Bayesian network algorithm that use the Bayesian classifier concept by using probability operation, so that they have maximum accuracy result. Related to the problem in such a way that is need to tool to help in providing proper and trusted solution, although many tools or application offer to do the classification process. And this research utilize WK application due to the personal preference subjectively, and these tools have been used to do the process classification in terms of case study by applying the raw data that have gone through the data mining process respectively. And here is our research methodology. There are three steps of our research methodology. The researcher used the first three useful for collection of data, namely data from 5 subjects, which are computer network, software-defined network, introduction to computer system, basic telecommunication system, and computer network design. And that is obtained from the system log of e-learning in the Telkom University. In addition, the second data is the final grade of data index of the student derived from Iglesias Telkom University, or single sign-on type platform in the university. Lastly, the third data is the student pop quiz score obtained from Moodle as the learning platform. And in this space, the researcher process student log data into 3 stages, which the first is separating the required data and then allocating the module data from student log data that meet the criteria based on 5 specified activities, namely quiz, assignment, forum, file, and interactive content. Then the second stage is to separate the data obtained from the previous process based on the 5 activity mentioned, while the third step is to calculate the data has been generated previously to produce the amount of access from each activity. And all of the states will be processed using Pentaho data integration. Furthermore, the resulting data will be combined with the final student grade index data and the average result of the pop quiz score. After that, the data will be combined to allow the classification process to be carried out. Okay, there is the our research methodology, and here is the this figure. You can see the process of separating student log data based on modules that fulfill the 5 specified attribute, which the process use several tools that have been provided in Pentaho data integration. And from figure 2, you can see the process of separating student log data based on predetermined activities, which also utilize several tools that have been provided in Pentaho data integration. And the figure 3 show the detailed process of separating student log data based on predetermined activities through the specific calculation. And after completing the 3 process, as you can see in this slide, the last process is to combine the result of calculating the number of access activity of each subject with the student index value. Afterward, they will be combined again with the data quiz pop value that has been calculated on average, and then combined into one file, in this case called datagabungan.csv, which has been done manually because Pentaho data integration do not have feature to allow this process. Okay, after we doing some pre-processing data, here is the result of our research. When we use WK tool by selecting the data to be used in the classification process, that will be done in the pre-process menu. It can be seen in this slide. The data to be used is 513 rows, which are divided into 7 attributes, namely a quiz, assignment, file, forum, in content, and rata-rata pop quiz, and graduation attribute as the comparison attribute. It can also be seen that the graduation as a comparison attribute has 4 labels, namely average with 101 data, bad with 45 data, excellent with 171 data, and good with 196 data. Then the classification step will be carried out on the classify menu, which there are several test options that can be used by choosing the preferred method. In the implementation stage, C4.5 algorithm will be done by 66% test option split, where this process will be carried out with 66% training data and 44% testing data. Here the result from C4.5 algorithm, and you can see the result, the accuracy the accuracy result from C4.5 algorithm is 73.87%. And here the classification result from naive Bayes algorithm, followed by some information obtained from the classification process in the stage of implementation the naive Bayes algorithm. will be carried out with a percentage split test option of 66%, where this process will be carried out with 66% training data and 44% testing data. And from the result of the classification process using the net bias algorithm, the accuracy only 44.05%. And here the last classification result from Bayesian network algorithm, followed by the same classification process as C4005 algorithm and naive Bayes. Bayesian network algorithm will be done with 66% test option split, where this is process carried out with 66 training data and 44 testing data. And from the result of the classification process in the Bayesian network algorithm, the result, the accuracy result are 56.14%. And here is the accuracy of algorithm comparison. From the result of the comparison of the algorithm performance, it was found that C4.5 algorithm had the highest accuracy with a result of 73% and with an average true positive rate of 0.739. Then the Bayesian network algorithm had an accuracy of 56% with an average of true positive rate is 0.561, and the last algorithm naive Bayes with 44% accuracy with an average of true positive rate is only 0.441. However, certain circumstances should be put into the context as naive Bayes, as a simple method in certain cases can be outperform decision tree, canary snakeball, Dominguez and Pazzini due to the data independence, or 0-1 loss function used in this classification, or even the process of distribution among all distribution over class. Even through the probability estimate that are produced inaccurate, naive Bayes often generate through maximum probability of the accurate class, which show good performance might be limited to context of categorical output. At certain occasion, the fast calculation time by decision tree can be occur due to the absence of classification process, which bigger training set lead to bigger memory requirement and larger distance calculation must be performed. And here our conclusion is extract an interesting understanding with Herto unknown pattern related to the cluster of data record or cluster analysis and unusual record or anomaly detection and dependencies or mining associate rule. Still, the algorithm use will determine on the classification result to rely upon in determine the anticipation strategy to work for. After conducting a multi-stage research on testing the performance of the C4.5 naive Bayes and Bayesian network algorithm to measure the accuracy of student data derived from the Telkom University. In this case, implemented on module e-learning data log, and the researcher conclude that the C4.5 algorithm is the most effective with classification value of 73% 3%, while it also has the greatest data accuracy with true positive rate of 0.739. And however, it is recommended that the interpretation results should consider the other aspect of external and internal motivation, such as role model, facilities or infrastructure, reward and punishment, culture, and etc. Okay, that is my presentation. If you have any question, please feel free to ask me. Thank you.
Okay, any question? I think we have no time for asking questions. Okay, if you have any question, you can contact the author directly, maybe via email. Okay, okay. Let's move on to the next paper.
Okay, thank you for your great presentation. So we'll move further to our next paper. The paper presenter is Robbie, and the paper title is Web-Based Village Bridge and Road Project Monitoring Information System. Dear presenter, you may please start your presentation.
Okay, thank you, Miss. Can I share my presentation? Okay. Hello everyone. Good morning, good evening, or good afternoon. So my name is Robi Gisnawan. I'm from the Indonesia, and I'm from Untitled University. So right now I will explain about my paper. The title is Web-Based Village, Bridge, and Road Project Monitoring and Information System. Yes, this is the background, my paper. In development in developing countries such as the Republic of Indonesia contain two dimensions, namely goals and process. The goal of development is definitely better living conditions as researched by the community, while the process to achieve that goal is set in various development strategies. The success of development cannot be separated from the active role of sector short, especially the development of the road and bridge transportation infrastructure sector. The wide area of land transportation service that must be accessible, which cover the entire territory of Indonesia. It is necessary to carry out spatial handling and improving the quality of land transportation service that are safe, easily accessible, thus competitive and integrated. And this is Ministry of PUPR data, and this so you can see the Ministry of PUPR data, many allocation for allocated for village infrastructure development of PUPR. And based on data from the Ministry of Public Housing and Public Housing, it can be seen that the right state of fund or allocation to the Binar Marga organization units, which include the managing road and the bridge. And the 2018 village fund allocation, according to Ministry of Finance, Ms. Sri Moyani, The village fund has been benefit the community, especially in the infrastructure sector in 2018. The infrastructure will include 1,000 119.6 thousand kilometer village roads, 1,000 0.4 kilometer village bridge, and according to ICW research, Wana Alamsa, the amount of corruption in village fund so that there is no comprehensive system carried out or made by the government in terms of the monitoring village fund. And the solution, my solution for the background and the problem is my country. I will create the web-based village bridge and road project monitoring information system. So the project cost management information system is ordered to be able to perform estimating, budgeting, and monitoring on village infrastructure development project, so that the funds budgeting by the government can be channeled optimally and minimize error in village infrastructure development. Now, this is the research review. The in developing project management application requiring a business model use the foundation in development process. Following design the management application business model. So this project initiation, project planning, project execution and control, and project phase, project closure. Initiation project is the first phase in a project. In this phase, the problem business identification and case a business to provide various choice solution are as defined. So, and in the planning process, we see a project in the form of baseline WBS, work breakdown structure. You can Gantt chart and the S-cube. And the implementation, project execution and control, so that this phase include each activity and work list in the project plan. When activities and work are performed, management is required to unify and control project outcome. This series of projects include change or RBOK and RE schedule, risk and issues, reviewing quality, and measuring each project result against predetermined criteria. So the project closure include handling of a project, result to the project owner, handing over the project documentation, terminating contract with this partner, releasing project results, and communicating project closure to all stakeholders. And this is the final step is to conduct implementation review to measure the overall success of the project and to list variable reason for the future project. So this is the research method, and this paper use the RUP or Rational Unified Process method. Was the choosing because it the correspondent to a case study that occurred where rebuilding and exciting application with a different platform based on the data in the form of application manual. The application, the development process, the document, application flow, document, and database requirement previous apps. Rational unified process is software engineering process model used to increase the productivity of software development team within and the organization. This is the stage research method. This is a training set including the primary study, literature study, and combination of the problem, objective, and the benefit. So, and the next stage, the requirement analysis, including the process identification of problem, requirement analysis, and the third process stage design, and including system design, so database design and UI design, user interface design. So the next stage is the implementation stage, the including the system development, and there's this is the three segment, the model three model. This is model cost estimating, and model second model, the model cost budgeting, and the third model, the model cost controlling. The next stage, the testing stage, is the testing stage using the black box testing, user acceptance test, load and trace testing, and finish the last process in the testing stage, just the evaluation information system. Uh, and the last stage is the conclusion. The conclusion is project management information system. So this is the result and discussion. This is the business process. In this research, the system can only estimate the project development planning cost and does not cover the entire project management. The project cost management information system developed has three features, including estimating, budgeting, and monitoring. The business process analysis is an analysis that can be used to describe process activity. This is the stakeholder perform specific, especially to achieve the contract goal. This is the actor at the process. I have the three stakeholder at the three stage: initiation, planning, execution, control, and culture. So the business process for in the project management application, the business process start at the initiation, inputting the new project data which will be managed by the application. After creating a new project, the human resource input list info with the project, followed by the BOQ list and the equipment list needed by the project, and continue in the planning process. In the process, we see the process in the form of a WBS or work breakdown structure, baseline, and Gantt chart, and the scope. After the planning process, it will go to the execution and the controlling process. In this process, to ensure that tree is not change the project data. If there is a change in the project data, it will carry out the edit planning process. Otherwise, it will process to the progress. Evaluation for process is certificate payment and the progress and the visual report and the project completed. And if the project is declared complete, it will enter the change status complete process, generate a closure report, and finally the closure project process. The following is the process. You can see the picture business process. So this is the technology for the development of my application. And application will utilize PHP technology with Laravel framework, Lumen, and the MPX. This is thing cloud support architecture multi-tier that will use implementation application system performance need and tier support, because the possibility will used by many user for the controlling project. In one project handled by app allow on user more from 4 people. And then if many existing project in the database, so more the lots of data and access people, then if many existing project is that in database, so the more loss of data access application. The configuration this shall become a number of people that is user tier client, and the presentation tier. This is include the web server, and using Apache and Laravel. So the segment, the business tier, the application server using the remote business application with Lumen, including the API. So and the resort tier and using database server, this the application using the MySQL. This is the picture the my web. This is the picture planning. So this is you can see this is the project list. The in table is your project name, description, and action. This action including set default. Set default is the uh, default the management for the application, and you can edit or delete. So this is the example feature in the application. So this result load and stress testing. The testing test send request to the application server with the initiation of knowing how capable the application. Server can receive the request to the maximum to the test. Server has channel S operating system specification with the storage capacity of 1 gigabyte. The load and stress testing and the resulting output is conclusion regarding the number of requests, data usage, the response time, error, and standard deviation. So this is I can I using the 20 user for the this application. So the conclusion, the in application, the business project management use the business model Canvas to design business management strategies in the business plan. The early adopter of project management customer segment are the consultant and contractor and owner. Then the project management value proposition is a user will subscribe at low cost. They will make it the easier for user. In addition to the business model, Canvas to describe to the outer and the application using business process analysis and use case diagram. The project management application consists of several features, namely planning, execution, controlling, and the reporting. Maybe you can and the three info and reporting feature use to create final project report and inform the status of the project complete or not yet complete. The project management application system architecture consists of several components, namely web server, database server, internet service provider, and client. And the purpose of the architecture is for the information technology to meet to the strategic business need of the organization. Therefore, the project management information system architecture to combine information need is component and supporting technology. So this is my presentation. Uh, Thank you for the time and thank you for the opportunity. So okay, I think finish for the explain my paper. Thank you. Thank you.
Okay, thank you very
Okay.
much. Oh, thank you, thank you. Yeah, we
Thank
are a
you.
little bit delayed, so let's go on to the last one. Okay.
Okay.
Thank you for your great presentation. Now we'll move further to our last paper for this session. And the paper presenter is Ari Happonen, and the paper title is Taxonomy of Data Quality Metrics in Digital Citizen Science. Dear presenter, you may please start your presentation.
All right, just a second. I will share the screen and just check that. You see the full screen on my slide. Anyone? Can you confirm?
No, it's not
No.
yet visible.
All right.
Yes, now it is. Please continue.
Okay, thank you. So our publication is related on citizen science and more specifically on the data quality. So I will go through the presentation if you want to see the details on any of the authors. And especially, I'm not the specialist. The first author is the one who did the whole framework. So he will give you the most detailed questions if you have specific questions on the framework. I was mostly helping, guiding, and participating on the Sensei project, which will be soon mentioned. So in this citizen science context, our let's say generic problem statement, which we also faced on the practical implementations, is that when the citizens themselves, they lack kind of a formal scientific training. So when you give an instructions, you explain what kind of a data you are collecting, their interpretation for this data is not the same, which is your expectation or your interpretation. And this will definitely reduce the quality of the data which you will receive in the end of the collection period. So given this baseline, we had a few research questions. First one being, what is the typical data quality issues that you could face on citizen science or nowadays even more digital citizen science projects? How would you be measuring the quality of this data which you collect? Because you need some sort of formalities to be validate the data which you get to be able to say that what is the real quality of it. And the last and I think most important aspect of our research is these different mechanisms and metrics that you could utilize to improve your data. So basically meaning that if you are going to make a digital citizen science project, our framework could prepare you to reduce the probable problem sources. From the methodological point of view, how we finally end up with the framework. First of all, there is two different kind of case studies utilized. So we went through reports from the practical experiments, so their case studies, which we studied, and our own urban experiments. The interviews, so participants of our project, they interviewed both the data quality analysts and then other researchers who are doing citizen science research or projects. And one of the biggest contributors is, of course, the literature. So there was a big bunch of literature which we went through of what are the problems in what of different stages, where do the quality issues come, what are the known issues and solutions, and so on. And all of these three different information gathering methodologies, they were combined for this framework of kind of our first version. The one which I will be going to show is the last one, but this was the stage on the process. And then we did this Sensei project. And its results were improved through these interviews of domain experts, and those both contributed to final framework. So just to give a general overview, what could you find on the literature on this topic? On that time when we did the literature review, we found little under 100 papers to go through. And as you can see from this picture, First of all, a lot of citizen science projects were already published or shown on the publications on that time. You don't find too many citizen science and data quality related publications we found on that time under then. And these known issues and solutions on that time was not too much covered. And that was one of the reasons why we wanted to make these publications. On the other hand, software and data quality is talked a lot. And that, of course, is a nice thing because it contributes on also digital citizen science projects. And then you have the data quality metrics and mechanisms, which I will partly mention on forward in this presentation, but also by understanding those mechanisms on data quality in general helps you on these citizen science projects. So for interviews, there was 2 citizens project teams. So they were experienced on that. Previously mentioned database related things. 3 different admins were interviewed and 2 people who are doing big data analysis. Those people have specific knowledge on where does the analyzed fail because of the data quality issues, and that comes back to the framework contributing on knowledge. So in general, when we went through different case studies, on that time 28 projects were studied, and we did 2 urban experiments, so those are ours. One of those is this Sensei, which I previously mentioned, and then we had a DOE project, which was run by my colleague professor. And from these, you get the documentation of the projects, which give a hints which went well, which didn't went well. Of course, you can go through information on web pages. Usually that's more superficial. And if you can get on the context of urban experiments, that's usually the most contributing in the sense that you get this below the surface experience knowledge from people who have been part of these things. And I think for anyone who is going to plan or is currently doing these citizen science projects, it's one of the most important. So you should always remember that you can generate or you can actually have data quality issues even before the actual experiment. For example, the first one on the top left corner, hardware calibration. So if you calibrate your hardware incorrectly or do not calibrate it at all, but it should be calibrated, you can end up in a situation that you have either biased data, which could be maybe fixed later on, but if there is random mistakes because of missing calibration, that could be really problematic. From a user point of view, there is the problem which can happen during the experiments or in the borderline of experiment going to be ended. This one which we mentioned here is the green one, which is on the loss of data row. So if the people forget to submit, you lose data. So you have a quality issue from the sense that you never get the data which they actually did collect, but never submit for you. And
sorry for the interruption, but
yes.
It's a kind request to please conclude your presentation as we are running short of time.
Yes, fine. So if you are interested on these solutions, which we identified for issues, this is kind of exhaustive list, but it's also mentioned on our publication and it's available for download. And I will just I mentioned these urban experiments. There is a few publications on themselves. If you need those, just please feel free to contact me. I'm happy to deliver them. And let's say a big picture, which you can identify these problems. I just mentioned hardware calibration, a lack of motivation. So gamification could solve those issues, but it's not the only one. So I mean the users, they can have a lack of motivation. If you have to make an unplanned release of updates, you could yourself make mistakes and lose some data. And then just for like an example of technologies, so GPS doesn't work really nicely in between major cities buildings, so position actually can be a challenge in these digital citizen science processes because you usually want the location information. So overall, the solution is our framework. I will just jump on the big picture. So this is your before, during, and after different mechanisms to not to have the problems which I partly mentioned previously. The whole thing is mentioned on this publication, and utilize these kind of frameworks for considering the sustainability of your whole, let's say, whole project, and especially the data quality and data keeping sustainability things. But all in all, so in conclusion, we were really happy on when we were being able to do so exhaustive list of options for people to not have the problems, and also by showing this framework, you will see what could be your problems, and then you can start fighting them immediately when you start making your project. But all in all, I'm open for a question. Thank you.
Okay. Okay. Thank you very much. Okay. Yeah, I think it's time. Okay. Thank you very much for attending. Okay, this section. Okay. I want to especially thank all the speakers for your hard work and contribution to this conference. Yeah, it's time for us to close this session. Okay, thank you. Hi, Anisha.
Okay, sir. Thank you for your valuable presence, sir. So as we have come to the end of the session, I sincerely thank all the presenters for their excellent presentation and contribution in the session, and all the participants for being a part of this international conference. I hope the session was informative enough. We, on behalf of the whole team, thank you for your support during this version and the previous 5th version of the conference. We will be happy to have you in the 7th version in 2023. All the participants would be getting their digital certificates within 2 working days through email. Further, all the papers have already forwarded to Springer. The publication will be live within 6 months. Kindly cooperate with the team of WS4. I also like to thank our session chair for chairing this session. Here is a token of appreciation for the chair on behalf of the team of WS4 and Global Knowledge Research Foundation. Thank you for being here, sir. We are pleased to have you here.
Okay, thank you. Goodbye.
Okay.
Bye-bye. Thank you.
Goodbye, sir. So as we now we are ending the session, I request all the participants to switch on their cameras for a quick snapshot of this virtual conference. Okay, thank you so much. Stay safe and take care.